data should also have certain form of correlations. In other side, like say for example, humidity, temperature and others in systems if you like to go for. So even if there are multiple sensor used for capturing the data, but it is expected that there should be some form of correlation, and that correlation can be exploited. So inter-signal sparsity structure can be now when you go for DC, now it's a work of computer science. You can now think of how it can be implemented in DCS, I mean distributed CS. You can think of that sensor are independent, means during acquisition they do not collaborate, they only capture their data and they do not, so they reconstruct individually, and then you can choose which one is better at a particular time and take that. That may be one approach. Or other approach can be during capturing they are independent, they capture independently the parts data, but they send it to the fusion center, and fusion center amalgamate them. So fusion center exploit the inter-signal and intra-signal. Intra means individual signal sparsity, and inter-signal means one sensor signal to another sensor signal sparsity. Signal sparsity can be exploited in the second approach. So the last part of my talk, that is compressed sensing based IoT. Now, the first thing what I like to say, so in architecture level, as I say, that in IoT architecture there are several layers of architecture, but in my talk I only consider 3-layer architecture. One layer is sensor layers, where heterogeneous sensor will be collected the physical data and will exploit the sparsity. Some data to be routed to the intermediate processor or processing layers. I mean that is their mobile edge computing and something like that, where the chip computation and others can be done. And after that, that's my processing layer, and then it goes to the application layer, which to be hosted with your cloud. Now, first things I need to answer that why CS or how CS can be made use in IoT. As I say, that in IoT the first level is the sensing, data acquisition, and most of the physical level data, real world data, which will capture temperature, humidity, ECG, EEG, blood pressure, and all these physical phenomena, physical data, this can be represented partially in some suitable representation. Now, you may ask the question, is there any unique representation where all this? No, the answer is no. Or when we do the Fourier transformation, the basis function is fixed, e to the power minus j omega. When we choose the DCT, discrete cosine transformation, basis function is fixed. Even for DWT, basis function is fixed. Now, what can be done? Which will be, my data space at hand, in which representation space it will be partially represented. It's again an issue of dictionary learning, and people are doing so. But it is true that IoT sensor, what data this will capture, it can be partially represented. So, as I said at one point of time, the whole objective of CS-based IoT platform is to shift this computational and communication burdens to this end, where there are enormous computers. And this is possible exploiting two properties. The first property is what? Sparse representations. The physical data can be represented in sparse space by suitable representation. And second thing is the architecture sporadic transmission, means all sensors should not be active in all point of time, because we may say these sensors are essentially connected wireless means through them as well as this computing environment. But some links are so poor, or some sensors are so poor in their contribution may be less. So we don't need their contribution to always include. So fusion center may ignore their contribution. So if we can regulate the activity cycle of the sensor, by that way we can save energy. By that way we can enhance the lifespan. So what I'm going to say, there are two issues that suggest that say that compressive sensing can be made use in IoT design. One is your, as I already said, that DCT, DWT kind of representation space, and second thing is sporadic transmission scheme that most IoT platform exhibits. That means not all devices transmit simultaneously to fusion center. Architecture sparsity can be exploited. Remember the architecture sparsity means at one point of time some nodes to be effective and other to be in sleep or in silence mode. So network architecture can be exploited. So these two attributes make CS potential to IoT implementation framework. Now, first level is the sensor level. As I say, that sensor, actuator, RFIDs and communication technologies all are there integrated, right? And particularly if we see, there are hardware and software heterogeneousness are also there. Basically, the hardware is made by RFID and wireless systems, the two, realization. Now, RFID, if we see that basically consists of RFID tag, which is having an unique identification code, and it also having a scanner which read the devices. So RFID reader, right? Now, what would happen? This can be again to be placed inside the body or on the skin, or it can be somewhere. Even if the range of this transmission, so this RFID they provide, capture the data, provide the storage, tracking of this, and as well as communication, low range communication or low limited range, but this is also used. Now, on the other hand, there is WSN, wireless sensor network based application. It can be used in outdoor as well as the indoor. Say, for example, in outdoor, when we look for its smart city, humidity, temperature, and all this to be captured. In such situation, or even in case of indoor, when you have the health monitoring system or as well as the temperature monitoring and all this, what we can think of that large number of sensor devices are there, they are continuously capturing the data, so there should be redundant data and that sparsity can be exploited. Now, wireless application, whatever wireless sensor network application can be easily mapped or to be adapted to the IoT application. But there are danger also. There are problem also. Problem in the sense, in wireless sensor applications, the nodes are basically captured similar type of data. So these sensors are identical and they are capturing a single physical or similar type of data. But in IoT, the nodes are sensors are heterogeneous in nature. So in WSN, so what I was going to say that whatever WSN applications are there that can be easily adapted to the IoT, but the issues are there in WSN. Sensors are homogeneous in nature. On the other hand, in IoT, the sensors are heterogeneous in nature. Furthermore, if you are not properly placed the nodes, deployed the nodes in WSN, the performance will go, but lifetime will also go like that. So some research needs to do it in order to incorporate or extend this wireless sensor network in the framework of IoT application. And what we can do in sensing layer perspective, how CS can benefit? Adaptive measurements. As I say, large number. So dense wireless sensor network where the nodes are densely deployed. So what we can think of that how much sparsity we can exploit. The question is, if you go less number of measurements, you will have much gain in the storage and transmission, but again reconstruction will suffer. So it needs an optimization problem. That one hand, less the number of measurements, you are gaining in terms of storage, transmission, delay, but reconstruction quality will be poor. So you have to go for an optimization. That what would be the required number of measurements such that the required quality to be made. So to determine optimal number of measurements, I will cite an example, a case-based example here. Now, say multiple sensors are here. So individual CS data transmitted to the fusion center. Now fusion center can do an weighted combining. So optimal weight can be designed based on the quality of the sense data of the or quality of the sensor. The fusion center can allocate weight. So optimal, so distributed comprehensive sensing and optimal weighted measurements. CS-based data gathering, you can think of a multi-hop network where nodes will collect data on CS. So CS data will be collected by a node, and that CS data to be transmitted to the next node. By that way, it will go on, and single node should have all CS data. So by that way, that CDG, that CS-based data gathering or compressive data gathering, disperse the communication and computation resource. So what I'd like to say is that nodes does CS, and whatever CS measurements one node captured, it transmits to the next node. next node will take its and this one. So like that way, a sync node have the all CS data from the different nodes. Now sparse network architecture, as I say, that few sensors to be active in time slot, and CS-based routing protocol. You can apply a greedy algorithm while establishing the route setup or channel setup. So channel, you can sense which frequency is available or not. I will come to these issues on the context of spectra. So routing in the set, that greedy approaches to be there, path to be selected in such a way that the measurement matrix and sparse matrix should have the incoherency. Now, one example, as I say, that weighted combining. Suppose you have a sensor, some of our typical applications, what we have done, compressed sensing image reconstruction, that you are having a same scene, you are having a multiple cameras, and this camera is having different focus and from different field of view. So I assume that there is a moving platform because these cameras are in a mobile environment. So some degradation will be there because of the relative motion between the scene and the capturing element. Now, this is my degradation, and this is the sensing matrix. So we have the CS data of individual camera, and then we send it to the fusion center and go for a linear regression methods for optimal combining techniques, so that we have a good reconstruction quality. So mathematically, what I'd like to say, my measurements, and you imagine that I have m number of measurements, but again, that actually my signal is endpoint data, and I am having m number of data for CS measurement. I capture m data from this, and that way we just amalgamate, and then we have weighted fusion techniques, and this weight is calculated by means of any techniques can be done. It is linear regression techniques or something. As I already say, suppose if you are having a communication channel and you are doing some form of diversity techniques, so you can think the signal to noise ratio. One can think of like a signal to noise ratio. Just one. हाँ सर, हाँ हाँ point of हाँ ठीक है, okay. So this is basically your one approach is one can think of it. Now spectrum is an important issue. Apart from the data acquisition process, apart from the data acquisition, seamless connection is essential for IoT application. So in such cases, how the spectrum information to be provided? One concept is the cognitive radio. In cognitive radio, we can think of that there is a primary user who is actually having the spectrum. So a IoT nodes before transmission will sense the frequency which is available. And one application is the spectrum sensing. So if you think of an application environment where this IoT nodes as a cognitive radio framework, cognitive radio IoT framework, they are monitoring the primary user activity, and they are making sense sample are transmitting to the fusion center. Fusion center makes a global decision whether spectrum is free or not. Sample collection does not incorporate or much energy. Rather, the energy consumption is because of transmission of this sample from this place to the fusion center. And this is a framework which is done by this. What we have done here, the sporadic transmission, that some of the sensors, some of the channels are very poor. We don't like to include. Fusion center give a feedback signal and say that you need not have to transmit, and by that way we can have a sporadic architecture which can be made use. Similarly, mobile edge computing, as I say, that basically there's some part of the task to be split into two parts, and app or something like so. It does not otherwise like to say that it does not delimit the use of cloud environment, but some of the transient data analysis or real-time data analysis is done here. And one typical application which I'm going to say here is that is secret image sharing approaches, and for intermediate says, particularly in the physical, I mean the processing layer, the having less computational facilities. So what it is done, instead of doing compressive sensing in your parse representation space, looking for DCT, Dept, and all this, we think of a parse representation in original domain. What you'd like to say, you are having image, you represent a prediction-based image. If your prediction is good, the difference between original image and predicted image are very small, and that's give you the parse representation. So if you like to share this image as a secret, instead of make this share in this form, you just calculate a predicted image, take the difference, and that would, if your prediction is good, so prediction would be worthy and you can go for this. And that way, you see, this is the cloud environment. Some of the information you can store here, the sensing matrix and all this, and you can reconstruct back. By this way, you can have a facility of your security aspects. And this sensing matrix is very important. If the sensing matrix is not available, it other way, I mean, unauthorized user which is not having this sensing matrix cannot reconstruct this. I mean, this we have studied in other works, that non-availability of the sensing matrix, how it affects the reconstruction of the signal. So if a user is not having the knowledge of the sensing matrix, cannot reconstruct back the signal. So this way one can think of like it. Now in application layer, as I say, last layer, so although the CS was developed for sensing and aggregation and all this, but this is also used in other applications like identification and detection, in multi-user communication. Multi-user communication is a receiver techniques in CDMA. So in CDMA, there are multiple users, they share the same time, same bandwidth by orthogonal code. But still, orthogonality in code, when breaks, there are interference. So this multiple access interference, we can go for sparsity representation. People have gone that, and that way it can provide the detection and identification. CS-based cloud storage, as I say, that you can only put k number of queries, and only k number of queries can be essential to retrieve back that. So this is basically application specific layer. And I just take two examples of remote healthcare support by CS-based IoT. Like one thing is, just instead of going in this, say for example, these days any talk will not be complete if there is no kind of machine learning approaches. And of course, I like to say at the end that CS, IoT, CR, machine learning, they to be integrated in single framework. So for example, if you have a low resolution image and you like to generate a high resolution image, and this to be done in a sensor network, and you do not have a luxury of computation by doing fast representation of DCT, Dept and all this, you can simply go for low resolution images by phase domain, and from there by means of CNN, convolution neural network, and this is a generative adversarial network. This is the GAN generative model, and this is the reconstruction, and by exploiting that you can reconstruct the signals. So this is a CS framework of reconstruction in original. One such application, you can have remote healthcare support, pneumonia detection. This is a chest ray image. You go for pulse representation, and what is done when pulse data, say for example, somewhere, the remote end the patients are there, the pulse data is transmitted to the CT or elsewhere the doctors are there. Now there are two ways. The computer-aided diagnosis, instead of full reconstruction, this is for doctor will diagnosis from here, but this CS data, and in the CS measurement space, that means even in the compact measurement space, people can do the CNN network for detection. So this is a classification problem, whether it is pneumonia patient or non-pneumonia. We do not even bother about mapping of the inverse mapping of N. Even in the compact representation space, we can reconstruct that. So this is CS classification or CS diagnosis, even without going back to the N space. And when it is required for medical practitioners or medical persons' opinion, we can go for reconstruction and make diagnosis. So that's all what I'm going to say at the end. It is the summary. What I'm going to say is here that basically, so CS IoT design research work is done. So energy is very important issue. Energy harvesting can be incorporated in IoT nodes. Implementation in multi-core framework. Then CS encoder design, as I say, that it's very, very important things, looking for the first representation space. And all these work, the machine learning, dictionary learning can be made use. And it is optimal power allocation for CS measurement transmission. As I say, data security, because structured sensing matrix are non-available. Now, encryption techniques, the CS is also used. Why? Now, because your data, in original domain, you are not capturing. You are capturing the other representation phase, and you are taking random projection. So it essentially adds an encryption. So CS adds an flavor of encryption techniques. So that's all which I like to say, that in future there may be an integration of compressed sensing, IoT, machine learning, cognitive radio, all in a single platform, and that way for the application specific design to be done. Thank you so much. I think I take too much time.
Well, thank you, Professor MAITY, for your very informative talk, highly illuminating talk, explaining all the basic techniques of this compressed sensing and how it can be applied onto different IoT applications. So, although there is, everything is online, and all of us join Professor Mighty to thank him. Applaud. This.
Yeah, thank you, Professor,
Thank you, sir.
for
Thank you, sir.
such a
Thank you,
nice
sir.
presentation and taking time in the weekend. And 5G IoT coding are very much hot in the area. And thank you for introducing such a nice topic to our faculty and students, sir. Thank you very much, sir.
It's my pleasure. Thank you so much, sir, for inviting me and giving me this scope of.
No, let us. Uh,
Hello.
Yeah, sir.
Yes.
Your voice is
I think
breaking.
Horse had some question. Horse Sina has raised a hand.
Yes.
Is having any question? Yes. Oh. Yes, left the meeting.
I think.
Yeah. Any question?
I think there is no pending questions.
Oh, there is no question. So that means the communication is useless. The receiver has no impact of this